Now, in this lecture, we'll find out the ratio between two radii. In the drawing, we have a big circle. Inside this big circle, we have two smaller circles. We know that the radius of this circle is B, the radius of this circle is A, and our mission is to find out the ratio between the radius of this circle and the radius of this circle, that is to say the ratio of B over A. In addition, you know that inside the biggest circle we have the right triangle ABC that is partially located in the biggest circle. You know that the length of side AB is 5 units, the length of side BC is 12 units, and we also know that this circle that its radius is A is inscribed or is blocked by this right triangle ABC. Again, our mission is to find out the ratio of B over A. So first of all, we implement the Pythagoras theorem on the right triangle ABC. According to the Pythagoras theorem, the right triangle ABC by PT is the relation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle ABC, this angle ABC equals to 90 degrees, and the hypotenuse in the right triangle ABC is AC, therefore the square of the hypotenuse is AC squared, and must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to AB squared plus BC squared. Repeat again, according to the Pythagoras theorem, in the right triangle ABC, AC squared equals to AB squared plus BC squared. So AC squared, that is the square of the hypotenuse, equals to AB squared. AB is 5, therefore AB squared is 5 squared, that is 25, plus BC squared. BC is 12, therefore BC squared is 12 squared, that is 144. So in conclusion, we found out that AC squared equals to 25 plus 144, that is actually 169. Here we take out of this equation, and we get that AC, the hypotenuse of the right triangle ABC AC, equals to the square root of 169, that is 13. So the length of the hypotenuse of the right triangle ABC, the length of the hypotenuse AC equals to 13 units in its length. So you know that at point N, the hypotenuse is bisected into two halves. The first half is AN and the second half is NC, because we know that AN equals to NC. So AC over 2 is actually 13 over 2. Point N, the hypotenuse is bisected into two halves. The first half is AN, so 13 over 2 will be equal to AN, and the second half is NC. The second half is NC. That is to say, we found out that NC equals to AN equals to 13 over 2. So the first half AN equals to 13 over 2, and the second half of the hypotenuse AC also equals to 13 over 2. In the next step, we define the center of this circle as Q. We define the center of the smallest circle as P. and we'll define the center of the biggest circle as O. In the next step, I present to you rule number 8, and we will implement rule number 8 in our drawing. So, as mentioned before, the right triangle ABC belongs to this circle, that its radius is A. We have rule number 8 that talks about the right triangle that blocks the circle. According to rule number 8, the radius of a circle that is blocked by a right triangle is R equals to A plus B minus C over 2. So we have here the right triangle ABC, angle ABC equals to 90 degrees. The length of side AB is the unit, side BC equals to B units in its length, and side AC equals to C units in its length. Then, according to rule number 8, you can find out the radius of this circle that is equal to R only by knowing the side lengths of the right triangle ABC. That is to say, the radius of this circle that is blocked by the right triangle ABC will be equal to A plus B minus C over 2. Again, the radius of this circle that is blocked by the right triangle ABC will be equal to R equals to A plus B minus C over 2. That is to say, the radius of any circle that is blocked by a right triangle will be equal to the sum of the lengths of the perpendiculars minus the length of the hypotenuse over 2. So we can implement rule number 8 in our drawing. In our drawing, the right triangle ABC blocks this circle with radius A. So according to rule number 8, the value of the radius A of this circle that is blocked by the right triangle ABC will be equal to AB plus BC minus AC over 2. Repeat again. According to rule number 8, the value of the radius A of the circle that is blocked by the right triangle ABC will be equal to AB plus BC minus AC over 2. It's given us in the question that AB equals to 5 and BC equals to 12. We just right now found out that the length of the hypotenuse AC is 13 over 2. So we found out that AB is 5, BC is 12, and AC is 12. So in total, A equals to 5 plus 12, that is 17, minus 13 over 2. 17 minus 13 is 4, and 4 over 2 is 2. We found out that the length of the hypotenuse A of the smallest circle is equals to 2 units. Okay, A equals to 2. So we can write here that A equals to 2 units. In the next step, we define the point of tendency of tangent AB with this circle ST, and then we join points P and T together by a straight line. Point P is the center of the smallest circle, this circle. Point T is the point on the circle itself, therefore PT is the radius of this circle that is equal to 2. The radius PT is drawn to point T, that is the point of tendency of tangent AB with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius TP. If AB is perpendicular to TP, it means that this angle equals to 90 degrees. this angle also will be equal to 90 degrees. Likewise, we'll define the point of tendency of tangent BC with this circle Sn, and then we'll join points P and N together by a straight line. Pn is the radius of this circle that is equal to 2. The radius Pn is drawn to point N, that is the point of tendency of tangent BC with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius NP. If BC is perpendicular to NP, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees. So actually in quadrilateral TBNP we have 1, 2, 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the missing angle here. In total, the sum of those 4 angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees, therefore the missing angle here must be equal to 90 degrees. Again, in order to complete the sum of the angles in this quadrilateral to 360 degrees, the missing angle here must be equal to 90 degrees. So inside quadrilateral TPBN we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to quadrilateral TPBN as a rectangle, and we also know that the opposite sides of a rectangle are equal to each other. That is to say, Pn equals to Tb, but Pn is 2, therefore Tb must be also equal to 2. Likewise, rectangle TPBN, Tp equals to Bn, but Tp equals to 2, therefore Bn must be also equal to 2. So BA equals to 5 units according to what is given us in the question. TB equals to 2, so BA minus BT equals to TA. Again, BA minus BT equals to TA. BA is 5, TB is 2, so TA will be equal to 5 minus 2, that is 3. Then we have rule number 2. According to rule number 2, the lengths of 2 tangents from common external point to a circle are equal. We have the common external point, point A. From the common external point, point A, we have 2 tangents to the circle, tangent AT and tangent AM. And according to rule number 2, they must be equal to each other. That is to say, AT equals to AM, but AT is 3, therefore AM must be also equal to 3. We have already found out that AM equals to 13 over 2. AM equals to 3, therefore AN minus AM equals to MN. Again, AN minus AM equals to MN. So write it down. AN minus AM equals to MN. Repeat again. AN minus AM equals to MN. AN is 13 over 2. We just right now found out that AM is 3, and this is equal to MN. So we multiply minus 3 by 2, and then we divide it by 2 in order to have a common factor with 13 over 3, with 13 over 2, and we get that minus 3 times 2 is minus 6, and it is equals to Mn. So Mn equals to 13 minus 6, that is 7 over 2. So in conclusion, we found out that Mn equals to 7 over 2 units. Mn equals to 7 over 2 units. This 9 Mn equals to 7 over 2 units. Okay. In the next step, I will present to you a new rule number 7, and we'll implement rule number 7 in our drawing. According to rule number 7, if a line segment that is drawn from the center of a circle bisects a chord then the line segment is perpendicular to the chord. The center of this circle is here at point O, and OM bisect chord AB. That is to say, AM equals to MB. And whenever you have a line segment from the center of a circle like here that bisect a chord, then the line segment must be also perpendicular to the chord. That is to say, here, because of the fact that OM bisect AB, that is to say AM equals to MB, therefore OM will be also perpendicular to AB. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees, according to this rule, or number 7. Again, whenever you have a chord from the center of the circle that bisect, whenever you have a line segment from the center of a circle that bisect the chord, then the line segment must be also perpendicular to the chord, like in this drawing. I can implement number 7 in our drawing. Our drawing, point O is the center of the biggest circle. We join points O and N together by a straight line. ON is line segment from the center of the biggest circle that bisect chord AC. Why? Because AN equals to NC. Again, line segment ON that is drawn from the center of the biggest circle bisect chord AC. That is to say, AN equals to NC. Therefore, according to rule number 7, we get that ON must be also perpendicular to AC. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees, again according to rule number 7. So we can write here that line segment ON is perpendicular to AC. In addition, we also know that point Q is the center of the circle, point N is the point on the circle itself, therefore QN is the radius of this circle. Repeat again, this line segment QN is the radius of this circle, and the radius QN is drawn to point N, that is the point of tendency of tangent AC with this circle. And whenever we have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius NQ. If AC is perpendicular to NQ, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. So we can write down that QN is also perpendicular to tangent AC. The radius QN is also perpendicular to tangent AC. So, from the fact that QN is perpendicular to AC and ON is also perpendicular to AC, we will derive that point O must lie on the radius QN. Write it down. Point O, that is the center of the biggest circle, must lie on the radius QN. Repeat again that we know that QN is perpendicular to AC at point N. At point N, QN and AC creates between them 90 degrees. This angle equals to 90 degrees and this angle equals to 90 degrees. Suppose that point O doesn't pass doesn't lie on QN, then for example if point O is here, then the angle ON that it will make with AC with tangent AC will never be equal to 90 degrees. Again, from this, if point O is there, we'll join points O and N together by a straight line. This angle that will be created between ON and AC will never be equal to 90 degrees. Only and only if point O is located on QN, then the angle ON will be perpendicular to AC, that is to say this angle will be equal to 90 degrees and this angle equals to 90 degrees. Otherwise, ON will never create 90 degrees with AC. ON will never create angle of 90 degrees at point N with AC. Okay, so that is to say QON is one straight line. Because of the fact that point O is located on QN, then QON is one straight line. Line segment QON is one straight line. Again, QON is one straight line. In the next step, we define the touching point between this circle and the biggest circle. This point is U. And this point, this circle and the biggest circle are tangent to each other. They touch each other at the point U. And then we draw a tangent BW that is tangent to both circles at point U. Again, we draw here tangent BW that is tangent to both circles at point U. This is tangent BW. Again, tangent BW is tangent to both circles at point U. So here, point Q is the center of the circle, point U is the point of the circle itself, therefore QU is the radius of this circle, that is equal to units in its length. The radius QU is drawn to point U, that is the point of tendency of tangent VW with this circle, and whenever you have a radius that is drawn to the point of tendency, then the radius QW will be perpendicular to tangent VW will be perpendicular to the radius Q or UQ. If VW is perpendicular to UQ, it means that this angle equals to 90 degrees, and this angle also will be equal to 90 degrees. So you can write down that QU is perpendicular to tangent VW. The radius QU is also perpendicular to tangent VW. Likewise, here we have point O is the center of the biggest circle. Point U is the point of the biggest circle itself. This is exactly the definition of a radius. So OU is the radius of the biggest circle that we will define as X. The radius OU is drawn to point U, that is the point of tendency of tangent VW with the biggest circle. Whenever you have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to the radius UO. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. So we can write down that OU is also perpendicular to VW. The radius of the biggest circle OU is also perpendicular to tangent VW. And from those two equations, QU is perpendicular to VW, OU is perpendicular to VW, we derive that in total Q or OQU is one straight line. This line segment OQU is one straight line. So, because of the fact that both QU is perpendicular to VW at point U again, OU is perpendicular to tangent with W at point U, and QU is also perpendicular to tangent with W at point U. It means that if, for example, point O is not located on the straight line QU, it means that if, for example, it is located here, then OU will never be perpendicular to VW. Or if we take, for example, point Q, if point Q is not located on the straight line OU, and if, for example, it is located here, then QU will never make angle of 90 degrees with VW. So, therefore, all the 3 points Q, O, Q, and U must be located on the same straight line. So, for one side, we found out that OQU is one straight line, but for the other side, we already found out that QON is also one straight line. From those two statements, we derive that NQU is one straight line. NQU is one straight line. So, if line segment NQU is one straight line, it means that NU is a straight line. NU is a straight line. But NU, line segment NU is a straight line that touches point at the circle at points N and U. Therefore, NU is a chord that passes through the center of the circle. That is to say, it passes through point Q. And we know that any chord that passes through the center of the circle must be the diameter of the circle. Therefore, NU is the diameter of the circle. So I can write down that NU is the diameter of the circle. NU is the diameter of the circle. But we also know that the diameter of any circle is twice as long as the radius, and the radius of this circle is b. Therefore, the diameter NU must be equal to 2b. NU or UN, it is the same, is equals to 2b units in its length. Again, this line segment UN equals to 2b units in its length. It is the diameter of the circle. Okay. In the next step, I'll present to you a new rule. We'll implement the new rule in our drawing. But first of all, we join points O and P together by a straight line. Point O is the center of the bigger circle. Point P is the center of the smaller circle, and the straight line OP connects the two centers together. The smallest circle, this is the smallest circle, have an internal notch with the biggest circle. That is to say, they touch each other internally. At this point, we define the touching point as point S. And then I'll present to you rule number 9 and implement rule number 9 in our drawing. According to rule number 9, if two circles touch each other internally, then the straight line that connects their centers together must pass through their touching points. Here we have point O is the center of the big circle, point M is the center of the small circle, and the straight line that connects their centers together is the straight line OM. According to this rule number 9, the straight line OM must pass through point P. That is to say OMP is one straight line. Again, OMP is one straight line. So we can implement rule number 9 in our drawing. Why? Because in our drawing, point S is the touching point between the biggest circle and the smallest circle. So according to rule number 9, the straight line that connects the centers of the biggest circle, the biggest circle and the smallest circle is the straight line OP. And the straight line OP must pass through point S. That is to say, OPS is one straight line. Okay? OPS is one straight line according to rule number 9. So I write it down. If OPS is one straight line, it means that OS or SO is also a straight line. So what is the length of line segment OP? From the drawing it is very easy to see that OP equals to OS minus PS. Again, OS minus PS equals to OP. I write it down. OS minus PS equals to OP. What is the definition of the straight line OS? The straight line OS starts from point O, that is the center of the biggest circle, and ends at point S, that is the point on the biggest circle itself. This is exactly the definition of a radius. So OS is the radius of the biggest circle, that is equal to X. What is the definition of PS? P is the center of the smallest circle, S is the point on the smallest circle itself. Therefore, PS is the radius of the smallest circle, that is equal to 2. So we substitute PS by 2. So in total, we found out that OP equals to X minus 2. This line segment OP equals to X minus 2 units in its length. In the next step, we'll extend the perpendicular ON by a straight line. So here we extended the perpendicular ON, that is a straight line by a straight line. The result, this is the result. When you extend the straight line by a straight line, the result must be a straight line. So this is also a straight line. If we focus on this side of the straight line, extended ON, at point N, the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have this side of ON at point N? We have this angle that is equal to 90 degrees plus the missing angle. In total, they must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle here must be equal to 90 degrees. You also know that CA is tangent to this circle at point M. Point M is the point of tendency. We join points P and M together by a straight line. So point P is the center of the circle, point M is the point of the circle itself. Therefore PM is the radius of this circle, that is equal to 2. The radius PM is drawn to point M, that is the point of tendency of tangent AC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius MP. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. In the next step, we will draw perpendicular on the radius MP at point P. Again, we draw perpendicular on the radius MP at point P. So this angle equals to 90 degrees according to our construction. So inside quadrilateral, we will extend the perpendicular until it touches the extended the extended straight line ON. Till the extended ON touches the extended perpendicular from point P. We define the touching point as T. So inside quadrilateral NMPT we have 1, 2, 3 angles, therefore this fourth angle must be also equal to 90 degrees. In the next step we will implement the Pythagoras theorem on the right triangle PMT, but OPT, but before that, here, for the other MOTN, that is 4 right angles must fit this rectangle, so we can discuss, so we relate for the other MNPT is rectangle, we know that the opposite sides of rectangle are equal to each other, that is to say PM equals to NT, but PM is 2, therefore NT must be also equal to 2, likewise, we know that the rectangle MNPT, MN equals to PT, but MN is 702, therefore PT must be also equal to 702. Next step we will define line segment ON as edge, and we will implement the Pythagoras theorem on the right plane triangle OPT. PT equals to 7/2 units. We've already found out that PO equals to x minus 2. Here, PO or PT is the same. It equals to x minus 2, so the hypotenuse PO here equals to x minus 2. And finally, what is the length of OT? OT equals to ON plus NT. This is to say, OT equals to ON, that is h, plus NT, that is 2. In total, ON equals to h plus 2, or 2 plus h. So OT equals to 2 plus h. So according to the Pythagoras theorem, on the right green triangle OPT, this triangle is a copy from the original drawing. PO square equals to OT square plus PT square. Repeat again, in the right triangle OPT, PO square equals to OT square plus PT square. PO is x minus 2, therefore PO squared is x minus 2 squared, and it is equals to OT squared. OT is 7 over 2, OT is 2 plus 8, therefore OT squared is 2 plus 8 squared. Plus PT squared. PT is 7 over 2, therefore PT squared is 7 over 2 squared, that is 49 over 4. So I compare the found that in the right triangle of PT, x minus 2 squared equals to 2 plus 8 squared plus 49 over 4. We'll open the brackets on both sides of the equation and get that x minus 2 squared equals to x squared plus 2 squared, that is 4, plus 4x is equal to 4 plus 8 squared equals to 2 squared, that is 4, plus 8 squared plus 4h plus 49 over 4. Okay. In the next step, we join points O and C together by straight line. And we implement the Pythagoras theorem on the right triangle O and C. We know that NC equals to 13 over 2, and O equals to region according to our definition. What is the definition of the line segment OC? Line segment OC starts from point O, that is the center of the vector circle, and ends at point C, that is the point of the vector circle itself. Therefore, OC is the radius of the vector circle, that is equal to x. So I copy the right triangle O and C in the equation. We'll implement the Pythagoras theorem on this right triangle O and C. Again, ON equals to A according to our definition. We already found out that NC equals to 13 over 2 in the beginning of the lecture. And we just right now found out that OC equals to X. It is the radius of the biggest circle. So in the right triangle O and C, according to the Pythagoras theorem, we get that OC squared equals to ON squared plus NC squared. So OC is x, therefore OC squared is x squared is equals to ON squared. ON is h, therefore ON squared is h squared plus NC squared. NC is 13 over 2, therefore NC squared is 13 over 2 squared, that is 169 over 4. Again, x squared equals to h squared plus 169 over 4. It again. So in the next step we substitute x squared in this equation by h squared plus 169 over 4. We do it now and we get that x squared is h squared plus 169 over 4 plus 4 minus 4x, it is equals to 4 plus h squared plus 4h plus 49 over 4. Okay, so here we have h squared on both sides of the equation, so h squared will get cancelled. We also have 4 on both sides of the equation, so 4 also will get cancelled. And we're left holding this side of the equation with 169 over 4 minus 4x, that is equals to 4h plus 49 over 4. Here we subtract 49 over 4 from this equation and you get that 169 minus 49 over 4 minus 4x equals to 4h. Here we add 4x to this equation and you get that 169 plus 49 is 120, so in total this equation equals to 120 over 4, that is equals to 4x plus 4h. 120 over 4 is 30, so 30 equals to, here we take 4 as a ground for 4. And get it inside the brackets, we have x plus h. And divide this equation by 2. Okay, so we divide this equation by 2. From now that 30 equals to 4 times x plus h. We divide this equation by 2 and we get that 15 over 30 over 2 is 15. 4 over 2 is 2. So in conclusion, found out 15 over h. we found out that 15 equals to 2 times x plus h. We divide this equation by 2 and finally we get that x plus h equals to 15 over 2. X plus h equals to 15 over 2. So, what is the length of line segment line segment UN? UN equals to UO plus ON. That is to say, UN equals to UO, that is the radius of the biggest circle, is equal to x, plus ON, that is h. So in total, we found out that UN equals to x plus h. So we can write here that UN equals to x plus h. And we already found out that UN is also equal to 2b. So we can write here that UN is also equal to 2b. And from those two equations, we derive that x plus h equals to 2b, x plus h equals to 2b, but we already found out that x plus h equals to 15 over 2, so we can write here that x plus h equals to 15 over 2, and from this equation 15 over 2 equals to x plus h equals to 2b, we derive that 15 over 2 equals to 2b. We divide this equation by 2 and we get that finally b equals to 15 over 2 over 2 is 15 over 4. So I found out actually that the length of this radius b is 15 over 4 units. So I can write here that b, the radius b equals to 15 over 4 units in its length. And we already found out that the radius of this circle a equals to 2. So the ratio b over a will be equal to b is 15 over 4 over a, that is 2. So b over a equals to 15 over 4 over 2, that is 15 over 8. Okay. So now that b over a equals to either 15 over 8, or in terms of numbers, it is equals to 1.875 40 units. I repeat again. The answer to this question is that the ratio between the two on the I, b over a, it is equals to either 15 over 8 units, and in terms of numbers, it is equal to 1.875 units. In the next step, I will summarize the lecture. In this lecture, found out the ratio between the radius of this circle and the radius of this circle, that is to say the ratio B over A. We know that here we have inside the biggest circle we have those two smaller circles. Now that the radius of this circle is B, the radius of this circle is A. In addition, we have the right triangle ABC is partially located in the biggest circle. Side AB equals to 5 units, side BC equals to 12 units. This angle ABC equals to 90 degrees, and we also know that AN equals to NC. Again, our mission is to find out the ratio of B over A. In the first step, we implemented the Pythagoras theorem on this side triangle ABC. According to the Pythagoras theorem, AC square equals to AB square plus BC square. It again. AC square equals to AB square plus BC square. So AC square equals to AB square. AB is 5, therefore AB square is 5 squared, that's 25. Okay. Again, AB equals to 5, therefore B square is 5 squared, that is 25. Plus BC square. BC is 12, therefore BC square is 12 squared, that is 144. So AC square equals to 25 plus 144, it is 169. We took out all of this equation and found out that AC equals to the square root of 169 is 13. So the length of the hypotenuse AC is 13 units. At point N, the hypotenuse AC is bisected into two halves. Each half equals to 13 over 2, of course. So AN equals to 13 over 2, and NC will be also equal to 13 over 2. Repeat again, AC over 2 is 13 over 2, that is AN, the first half. The second half of AC is NC, they are both equal to 13 over 2, of course. So AN equals to NC equals to 13 over 2, NC equals to 13 over 2 units in its length. In the next step, I presented to you rule number 8, and we implemented rule number 8 in our drawing. According to rule number 8, the radius of a circle that is blocked by a right triangle is equal to, here we have the radius of the triangle, the right triangle ABC, angle ABC equals to 90 degrees, the length of AB is A units, side BC equals to B units in its length, and the hypotenuse AC equals to 3 units. And this right triangle ABC blocks this circle, the radius of this circle is R. We can find out the value of R only by knowing the side length of the right triangle ABC that blocks the circle. That is to say, R, the value of R will be equal to A plus B minus C over 2. Again, R equals to A plus B minus C over 2. Can implement rule number 9 in our drawing. Because in our drawing we have the right triangle ABC that blocks with this circle, the radius of this circle is A. So we can know the value of A only by knowing the side lengths of the right triangle ABC. That is to say, AB, the radius of A will be equal to AB plus BC minus AC over 2. Repeat again, according to rule number 8, the value of A will be equal to the radius A. It is the circle that the triangle ABC blocks. The value of A will be equal to AB plus BC minus CC over 2. AB is 5, BC is 12, and AC, the hypotenuse AC is 13. 5 plus 12 is 17. 17 minus 13 is 4, and 4 over 2 is 2. So if we want to find out that the radius A of this circle equals to 2 units, then we defined the center of this circle is Q, we define the center of the small circle as P, we define the center of the bigger circle as O. We define the point of tendency of tangent AB with this circle as T, we join points C and P together by a straight line. P is the center of the circle, T is the point on the circle itself, therefore PT is the radius of this circle that is equal to A and then equals to 2. We have the radius PT that is drawn to point C, that is the point of tendency of tangent AB with the circle, and whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius TP. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees. The next step, we find the point of tendency of tangent BC with this circle as N. We join points P and N together by a straight line. Pn is the radius of this circle that is equal to 2. The radius Pn is drawn to point N. Therefore, with all that I mentioned, tangent BC will be perpendicular to the radius NP, that is to say this angle equals to 90 degrees and this angle equals to 90 degrees. So inside the quadrangle PTBN, we have 1, 2, 3 right angles. Therefore, the fourth angle must be equal to 90 degrees. According to the rule, the sum of the angles in any quadrangle is equal to 360 degrees. So in quadrangle PTBN, we have 4 right angles. Any quadrangle that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrangle TPBN as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, Pn equals to Tb, but Pn is 2, therefore Tb must be also equal to 2. Likewise, Tp must be equal to Bn, but Tp is 2, therefore Bn must be also equal to 2. So, it is given as the equation that AB is 5. We found out that Tb is 2, therefore AB minus Tb is 80. Again, AB minus Tb is 80. AB is 5. Tb is 2, so 5 minus 2, it is 18, that is 3. 5 minus 2 is 3, and 18 equals to 3. Then we have rule number 2, that states that the lengths of two tangents from common external point to a circle are equal. We have the common external point A. From the common external point A, we have two tangents to the circle, tangent AT and tangent AN. According to rule number 2, they must be equal to each other. That is to say, AT equals to AN. But AT is 3, therefore AM must be also equal to 3. So AM equals to 3, AN equals to 13 over 3. Therefore AN minus AM equals to MN. Again, AN minus AM equals to MN. Repeat again. AN minus AM equals to MN. AN is 13 over 2. AM is 3. 13 over 2 minus 3. Here we took 2 as the common factor of those two expressions, that is to say, we multiplied minus 3 by 2 and then we divided by 2. Minus 3 times 2 is minus 6, which is 13 minus 6 over 2. So 13 minus 6 is 7, so in total this expression equals to 7 over 2, therefore Mn equals to 7 over 2. This line segment Mn equals to 7 over 2 units in its length. Then I presented to you rule number 7 and we implemented rule number 7 in our drawing. According to rule number 7, if a line segment that is drawn from the center of a circle bisects the chord, then the line segment is perpendicular to the chord. We have the center of this circle is at point O, line segment OM bisects chord AB, that is to say AM equals to MB. And whenever you have a line segment from the center of a circle like here that bisects a chord, then the line segment OM will be also perpendicular to chord AB. OM is perpendicular to AB, that is to say this angle equals to 90 degrees and this angle equals to 90 degrees. Again, whenever you have a line segment from the center of the circle that bisects the chord, then that line segment also will be perpendicular to the chord. Here OM bisects AB, therefore OM will be also perpendicular to AB. That is to say, this angle equals to 90 degrees, and this angle will also equal to 90 degrees according to this rule, rule number 7. So you can actually implement rule number 7 in our drawing. Here we joined points O and N together by a straight line. Point O is the center of the biggest circle. From the center of the biggest circle, we have actually a line segment ON that bisects called AC. Why? Because AN equals to NC at point N. AN equals to NC. And because of the fact that ON bisects AC, ON will be also perpendicular to AC. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to rule number 7. So again, according to rule number 7, ON bisects AC. So here we have point Q is the center of this circle, point N is the point of the circle itself, therefore Qn is the radius of this circle, is equal to B. The radius Qn is equal to point N, that is the point of tendency of tangent AC with this circle. And whenever you have radius that is 1 to the point of tendency, then tangent AC will be perpendicular to NQ. If AC is perpendicular to NQ, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees. So we found out that the radius Qn is also perpendicular to tangent AC. So we write here that QN is perpendicular to AC, and we found out that ON is also perpendicular to AC. From those two equations, we derive that point O must lie on Qn. This is point O that it must lie on the radius Qn. Otherwise, if point O doesn't lie on Qn, then ON will never create angle of 90 degrees with the tangent Qn. So point O must lie on Qn. If point O lies on Qn, it means that QON is one straight line. QON is one straight line. We define the touching point of this circle with the big circle, this point as U. Then we go tangent with W, that is tangent both to this circle and to the biggest circle. So point O, point Q is the center of the circle, point Q is the point of the circle itself, therefore QU is the radius of this circle, that is 1 to point U. Therefore, whenever you have a radius that is 1 to the point of tendency, then tangent VW will be perpendicular to the radius QU. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay, again, the radius QU is perpendicular to tangent VW. Likewise, we have point O is the center of the biggest circle. Point U is the point of the biggest circle itself. Therefore, OU is the radius of the biggest circle that we defined as X. The radius OU is 1 to point U, that is the point of tendency of tangent VW with the biggest circle. Whenever we have a radius that is 1 to the point of tendency, then tangent VW will be perpendicular to the radius UO. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. So we found out also that OU is also perpendicular to VW. Okay, OU is also perpendicular to VW, so QU is perpendicular to VW, and OU also perpendicular to VW. You can derive from those two equations that OQU is one straight line. Here. OQU is one straight line. So we found out that OQU from one side is one straight line, but we already found out that QON is also one straight line. Again, OQU is one straight line, and QON is also one straight line. From those two statements, we derive that in total, NQU is one straight line, okay? NQ U is one straight line. If NQU is one straight line, then NU is also a straight line. Again, NU is a straight line, but NU is a straight line that touches the circle at points N and U. That is to say, NU is a chord that passes from point Q, that is the center of the circle, and any chord that passes from the center of the circle must be the diameter of the circle. So NU is the diameter of the circle. And I know that NU is the diameter of the circle. We know that the diameter of any circle is twice as strong as the radius, and the radius of this circle is V, therefore the diameter NU or UN must be equal to 2B. UN equals to 2B. Then I presented to you all number 9 and implemented all number 9 in our drawing. Going to all number 9. If two circles touch each other internally, then the straight line that connects their centers together must pass from their touching point. The center of the biggest circle is here at point O, the center of the small circle is here at point M, and the straight line that connects their centers together is the straight line OM. According to this rule, number 9, the straight line OM must pass for point S. That is to say, OMS is one straight. The straight line OM must pass point P. That is to say, OMP is one straight line. Okay, OMP is one straight line. So we can implement rule number 9 in our drawing. The smallest circle touches the biggest circle at point S. Point S, we have an internal notch between them. This point. Point O is the center of the biggest circle. Point P is the center of the small circle, and the straight line that connects their centers together is the straight line OP. According to rule number 9, the straight line OP must pass for point S, that is to say, OPS is one straight line. Okay, OPS is one straight line. Yeah, you can find out that OPS is one straight line according to rule number 9. So if OPS is one straight line, it means that OS is also a straight line. OS is a straight line. So what is the definition of OS? I say that OS starts, the straight line OS starts from point O, that is the center of the biggest circle, and ends at point S, that is the point on the biggest circle itself. This is exactly the definition of a radius. So OS is the radius of the biggest circle, that is equal to X. So you can substitute OS by X. What is the definition of PS? P is the center of the small circle, and is the point on the small circle itself. Therefore, PS is the radius of this circle, that is equal to 2. So we can substitute PS by 2, and in total we found out that OP equals to X minus 2. In this last segment, OP is equal to X minus 2 units in its length. Then we extended the perpendicular ON by a straight line. When we extend the straight line by a straight line, the result is a straight line. So this is a straight line. We focus on this side of the straight line at point N. Here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have this side of the straight line at point N? We have this angle that is equal to 90 degrees plus the missing angle must be equal to 180 degrees according to the rule that I mentioned. Therefore the missing angle here must be equal to 90 degrees. Okay, then tangent AC extended to this circle at point M. We joined point P and M together by a straight line. Point P is the center of the circle, point M is the point of the circle itself, therefore PM is the radius of the circle that is equal to 2. The radius PM is drawn to point M, that is the point of tendency of the AC in the circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius MP. This is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. In the next step, we draw perpendicular on the radius MP at point P. Again, we do perpendicular on the radius MP at point P, so this again equals 90 degrees according to our construction. Then we extended the perpendicular until it touches the extended ON, extended straight line ON. We define the touching point as T, so inside parallel MP and T we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees. Therefore parallel PM and T is a rectangle and the opposite sides of the rectangle are equal to each other. That is to say PM equals to TN. So PM is 2, therefore TN must be also equal to 2. Likewise, in rectangle MNTP, MN equals to PT. But MN is 702, therefore PT must be also equal to 702. Then we define the length of line segment and OSH, and we created the Pythagoras theorem on the right triangle OPT. This is the right triangle OPT that comes from the original drawing. We already found out that OP, the hypotenuse OP equals to x minus 2, PT is 702, and here OT equals to h plus 2. OT equals to h plus 2. So if we made the Pythagoras theorem on this right triangle OPT, according to the Pythagoras theorem, PO square equals to PT square plus OT square. Repeat again. PO square equals to OT square plus PT square. PO is x minus 2, therefore PO square is x minus 2 square. OT is 2 plus h, therefore OT square is 2 plus h square plus PT square. PT is 7 over 2, therefore PT square is 7 over 2 square, that is 49 over 4. So in total we found out that x minus 2 square equals to 2 plus h square plus 49 over 4. We opened the brackets on both sides of the equation and found out that x minus 2 square equals to x square plus 2 square, that is 4, equals 4x. And is equals to 2 plus h square equals to 2 square, that is 4, plus h square plus 4h, plus 49 over 4. Then we join points O and C together by straight line. What is the definition of the straight line OC? It starts from point O, that is the center of the megacircle, and ends at point C, that is the point of the circle itself. This is exactly the definition of a radius. So OC is the radius of the biggest circle, that is equal to x. ON equals to h according to our definition, and we already found out that NC is 13 over 2. So I copy the right triangle on C in this right triangle, in this new frame here, and we implemented the Pythagoras theorem on this right triangle on C. According to the Pythagoras theorem in the right triangle on C, OC square equals to ON square plus NC square. OC is x, therefore OC square is x square, and it is equal to ON square. ON is h, therefore ON square is h square plus 13 over 2 square. 13 over 2 square is 169 over 4. So in conclusion, we found out that x square equals to h square plus 169 over 4. Therefore, we can substitute x square here by 169 over 4 plus h square. We did it and found out that so x square is h square plus 169 over 4 plus 4 plus 4x equals to 4 plus h square plus 4h plus 49 over 4. We have h square on both sides of the equation, so h square will get cancelled. We have 4 also on both sides of the equation, so 4 also will get cancelled. We have to if 169 over 4 minus 4x is equal to 4h plus 49 over 4. Then we subtracted 49 over 4 from this equation. We found out that 169 minus 49 over 4 equals to 4x, minus 4x equals to 4h. Here we added 4x to this equation and found out that 169 minus 49 is 120, so in total this expression equals to 120 over 4, and it is equal to 4x plus 4h. We took 4 as a round factor for this expression, so inside the brackets we left only with x plus h. So 120 over 4 is 30, so in total 30 equals to 4 times x plus h. We divided this equation by 2 and found out that 30 over 2 is 15, and 4 over 2 is 2, so in total 15 equals to 2 times x plus h. Then we divided this equation by 2 and finally found out that x plus h equals to 15 over 2. Then we found out what is the length of line segment UN. The length of line segment UN is UO plus ON. So UN equals to UO, that is x, plus ON, that is h. So in total UN equals to x plus h. So it's an idea that UN equals to x plus h from one side. But we already found out that UN is also equals to 2b, it is the diameter of the circle, UN equals to 2b, so you can write here that UN is also equals to 2b, and from these two equations, UN equals to x plus h and UN equals to 2b, we derive that x plus h equals to 2b from one side, but from the other side we already found out that x plus h equals to 15 over 2, so you can write here that x plus h equals to 15 over 2, and from this equation 15 over 2 equals to x plus h equals to 2b, we derive that 15 over 2 equals to 2b. We divided the equation by 2 and finally found out that b equals to 15 over 4 units. So the radius of this circle b is equal to 15 over 4 units. D equals to 15 over 4. We already found out that a equals to 2. So b over a is 15 over 4 over 2. 15 over 4 over 2 is 15 over 8. So in conclusion, we found out that the ratio b over a, that is to say the ratio between the two radii, b over a, equals to either 15 over 8 units, or in terms of numbers, it is equals to 1.875 units. Okay, thank you very much.